Okay, so today, most of the time, we're going to discuss about the inequalities. So if you remember, we defined the equation in the following way. So the equation is the mathematical expression which equalizes the two statements. So what you need to learn from this course over the time is not only how to solve equations or how to solve problems, but also to be able to formulate various definitions, mathematical definitions properly. For example, if I would just ask you, what does it mean? What is the solution? You should be able to give more or less rigid solution, rigid definition. So an inequality is the statement which basically inequalize two statements, two expressions, or which involves one of the inequality signs. So there are 4 inequality signs. Let's learn how we just call them in English. So A greater than B, or A is greater or equal to the B. A is less or equal to the B, and A is less than B. Okay, so there are 4 inequality signs, and this is how we are going to call them: greater or equal, less or equal, or simply less. So today I think we're going to discuss about the solutions of inequalities. And if you remember, we as a rule, we usually have finite number of the solutions for the equations. So as we've seen in the case of the quadratic equations, we may have just no solution or one solution or simply 2 solutions, just 2 values of the x which would satisfy your equation. While for the inequalities as a rule, we are going to have infinitely many solutions. So let's try to solve this inequality, for example, using the same principles what we did for the solutions of the equations. So do you remember what we did? So we need to get rid of everything around the x. So first of all, I'm just going to get rid of the 3. So subtract the 3 from both of the parts. It becomes like 2x is more than 8. And now I'm just going to divide both of the sides to the 2. It becomes x is more than 4, right? Just divide both of the sides to the 2. Or here, subtract the 3 from both of the sides. Okay, so x is more than 4. So could you please give me a couple of examples of the solutions of this inequality?
In the coordinate plane, that 0 to 10 or
okay,
equal.
For example, x is equal to the 5 is the solution, right? Why? If I say whenever y, you can answer me that if you substitute this into the inequality, it is going to be true. If you substitute, it becomes like 13 is greater than 11. Is it true? Yes. So if x is equal to the 6, it's also the solution, because if you substitute this, it becomes like 15 is greater than 11. It is true. And actually, this inequality, which states that any value of the x more than 4 as a solution of this inequality, states that it has infinitely many solutions. And we don't have enough space to write down all of this infinitely many solutions. And people have figured out how to do this in a compact way. And a way how you can write down infinitely many points in a very compact way is to write them as intervals. Okay, for example, if you would just express the infinitely many solutions for this inequality where x is between 2 and 5, which also indeed has infinitely many solutions, then we're going to simply denote this with an interval 2 and 5. It basically means that all of the numbers between 2 and 5 are going to be the solutions of your inequality. Okay, so this is number line when we are going to put the numbers. So in between, you've got 0, and all of the right points are going to be positive numbers 1, 2, 3, 4, and so on, and all of the numbers in between them. To the left, you're going to have negative numbers, and between you've got like the real numbers and so on. So this interval is going to be called as an open interval, because the borders of this interval is not included to the set of the solution. So the border x is equal to the 2 or x is equal to the 5 are not the solutions of the inequality. So that is why this interval is called the open interval. So but this is not only way of expressing the sets of numbers using the intervals. This is not only way of the type of the interval. There are many other type of the interval. For example, so the closed interval, we might have half open interval, or we might have infinite intervals. So whenever we say that x is from A and B, I'm just going to denote this like this. So x is going to be from A and B. So the sign basically means either inside, either from A and B, which is equivalent to say that x is greater than A and smaller than B. Okay, and again, the borders of this interval are not included to the set of solutions. So that is why we say that this interval is an open interval. So whenever we say that x is from the closed interval between A and B, it basically means that x is greater or equal to the B and smaller or equal, so x is greater or equal than A and smaller or equal to the B. Okay, so and the solution is going to be from the closed interval. So the x is from the A and B half open interval means that x is greater than A strictly and less or equal than B. So whenever we say this strictly greater, which means that it is not greater or equal, right? So greater or equal or strictly greater. So it is possible that your interval might have an infinity sign as well. So the x is from the A to infinity. Do you remember the solution of the first inequality, which was like x is greater than 4, can be written as the interval from 4 to infinity. So we are going to now introduce the new sign of the infinity sign, infinity sign. So it is an abstract sign, an abstract number, right? So it is, so if you imagine the biggest number ever on the number line, this infinity number is even greater than h1, okay? So again, so we are going to denote this as the open interval again, whenever you denote the infinity, because the infinity cannot be just the one value, okay? It's many values. Any big number is an infinity. So you will see this in a computer. Yeah, so you can denote some finite numbers as an infinity even in the computer, okay? So this concept of the infinity is very important for the computer science as well. Okay, so here are the classifications of the intervals. So now I think we are ready to do a couple of exercises solving inequalities. So let's say I've got this inequality, and if I need to find a solution of this inequality, what I need to do is I need to just regroup all of the terms with the x to one side and all of the terms without the x into the another side. Okay, so let's do this. So this -2 is going to go to this side and -3 is going to go to this side. Okay, so it becomes -4x minus 2x is greater than -11 plus 3, sorry. Then I'm just going to simplify the terms. It becomes plus 2x, right? So -2x is greater than -8. So now we need to get rid of this -2 in front of the x. So that is why I'm just going to divide everything to the -2. But since we're dividing everything to the negative number, the sign of inequality is also going to be changed, reversed, okay? So if you have got this greater sign, it becomes less sign. So it is becoming x is less than 4, not greater than 4, okay? And how will we denote this using the intervals? The set of all the solutions, x is less than 4, from 0 to the 4.
No, it's more like it's smaller
Minus
than
infinity and 4.
Okay, they are equivalent. Okay, so claiming that x is less than 4 is equivalent to claim that x is from this interval, from minus infinity to the 4. Okay, so this is how we are going to solve inequalities in general. Nothing difficult for now. So the difficulties are going to arise. I mean, it's also easy one. So let's try to do this. So whenever you've got 3 parts of your inequality, you're going to do the same operations with all of the 3 parts. For example, you need to get rid of this 2 in the middle. So that is why I'm just going to multiply everything to the 2, all of the 3 parts. It becomes minus 10 less or equal to 4 minus 3x is less than 2. Now I'm just going to subtract the 4 from all of the 3 parts. It becomes minus 14 less or equal minus 3x less than minus 2. Right? Now I'm just going to divide everything to the minus 3 in order to get rid of this minus 3 in front of the x. If I just divide everything to the minus 3, it becomes 14 over 3 x 2 over 3. The reason why I didn't put all of this inequality sign is that since I'm dividing everything into the negative sign, the signs are going to change reversely. The greater or less than sign is becoming, less or equal sign becomes greater or equal. Less sign becomes greater. Okay, then the solution for this inequality is going to be all the numbers between 2 over 3 and 14 over 3, where 14 over 3 is going to be included. So here is the typo, here's a mistake. So it's becoming half open interval. So nothing difficult so far, right? So we are doing more or less the same operations as what we would do before. So by just like subtracting and or like multiplying the numbers in both of the sides or in both of the 3 in all of the 3 sides of the inequalities. So the difficulties are arising whenever we've got now the fractions. Okay. So if I just say here, could you please tell me values for the x where this inequality is going to be greater than 0, it's going to be positive. So I think you can just solve this. Okay, so I think you can solve this logically, right? Isn't it? So what are going to be the solutions? When
x don't equal to 2 and answer it is 2 integer.
It's greater than
so
2.
It's greater than 2, right? For example, if you substitute x to be equal to the 1 into here, what you will get? 1 divided to the 1 minus 2, it is minus 1, right? Simply. It's a negative number. If you substitute x to be equal to the 3 to here, it becomes 1 divided to the 3 minus 2, which is 1 divided to the 1, which is 1, which is a positive number. I mean, it's obvious. It's quite obvious that this value, so it's quite obvious that this ratio is positive when its denominator is positive, when x minus 2 is positive. So that is why x should be more than 2, right? Yeah. So let me write this here. So an exercise. So I've got this this ratio. So 1 divided to the x minus 2 is positive. So this is positive when x minus 2 is positive. So it means that x should be more than 2. Easy. So in a previous group, we tried to solve this one exercise. So 1 divided to the x minus 2 is greater than 3. Any ideas how we can solve this? For example, can we just simply take the reciprocal from both of the sides and find the x? It would be easy solution, right? Yeah. For example, I would just take the reciprocal. So it becomes like x minus 2, then 1 over 3. Should I change the sign as well? Since I'm taking the reciprocal? No,
No.
okay.
No.
No,
No.
I'm not going to change this again. Okay. So then it becomes all of the values. X is more than 2, 1 over 3, right? For example, X is equal to the 2.5 is from this interval, right? Because this
Yeah.
interval is 2, 2.5, and somewhere here. So 2.33. Right? Okay, so let's just substitute this into here. What you will get. Because again, so if this is the solution, you need to check this. You can check this by just putting this into your equation. Okay, could you please mute your microphone? Thank you. So whenever you would like to say something, please feel free to ask the questions or to be, you're welcome to join the discussions, okay? If I just substitute 2.5, what I will get? 1 divided to the 2.5 minus 2. It is 1 divided to the 0.5. It's reciprocal of 1 over 2. What's the reciprocal of 1 over 2?
It's 2, I see.
It's 2, yes. So I've got an expression that 2 is greater than 3, which is false.
Yeah.
Okay. Where's the mistake? Do you understand that there is a mistake? I mean, there's obviously
Yeah.
mistakes.
Well, like we divide 3 by 1. No.
We took a reciprocals, right? Because you
Oh.
multiply this to here, then you put this to here, and so on.
Yeah. We should multiply x minus 2 to all them.
We did.
We need to change sign.
Okay. Okay, so if I would just change the sign, it would be so 1 divided to the x minus 2 is greater than 3. So multiply everything to the x minus 2. It becomes 1 is greater than 3 times x minus 2. Then divide everything to the 3. It becomes 1 over 3 is greater than x minus 2. Then x is less than 2, 1 over 3, for example. Okay.
Yes.
For example, x is equal to the 1. Is it a solution from here? Is it from here?
No,
It's less than 2.
not-
Right? Now let's substitute
Yeah.
this. 1 divided to the x minus 2 is greater than 3. If I substitute the 1, it becomes 1 divided to the 1 minus 2 greater than 3. And this is minus 1 is greater than 3. This is still false.
Yeah.
Again, so this this doesn't work, right? So the strategy, I think, is wrong, right? So we can't just really multiply the things or take the reciprocals. We need to figure out another way how to solve this. So we still need to solve this. So
Teacher.
Professor,
Professor,
yes.
it's really?
Oh yeah, that's correct. So this is how we need to solve this. So what we need to do is we need to okay. So here, what we did actually, so it was kind of easy for us to solve this inequality logically, okay? But if we would just bring some systematic system into the solution, what we did is actually we found the signs of the denominator and the signs of the numerator when the right-hand side part of your inequality is simply equal to 0. This is what we did, okay? So the numerator is always positive, okay? And we found the interval when the denominator is positive. So positive to the positive, then it becomes positive, okay? So this is what we did systematically, actually, what we would do systematically. So this is what we have to do here as well. So we need to bring everything to one side and leave 0 in one of the sides. Then we need to figure out the signs of the numerator and denominator. Okay, so let's do this together. So I'm just going to put the 3 into the left-hand side. It becomes 1 divided to the x minus 2 minus 3 is greater than 0. Now I'm just going to give the common denominator. It becomes 1 minus 3 times x minus 2 divided to the x minus 2 is greater than 0. Okay.
Yeah.
Now, I'm just going to open the brackets and simplify the terms. It becomes 1 minus 3x plus 6 divided to the x minus 2 is more than 0. And 7 minus 3x divided to the x minus 2 is greater than 0. Okay. So we put everything into one side and left 0 in another side. So now we need to identify the signs or the intervals of the signs for the numerator and denominator separately. In order to do this, we first of all need to find the roots of the numerator and denominator. What is the root of the numerator? What is the root of this? 7 minus 3x is equal to the 0. Then x is equal to 7 over 3.
Yeah.
Right? And what is the root of the denominator of this part? So x minus 2 is equal to 0, x is equal to the 2. Okay? So what we need to do is now, we just need to put these numbers, 2 and 7 over 3, because 7 over 3 is greater than 2. Right?
Yeah.
So we need to identify the signs of 7 minus 3x. Okay? If I get any value smaller than 2 from here, and if I substitute this into the 7 minus 3x, is it going to be positive or negative? For example, 0. If you substitute 0, is it positive?
Yeah.
Yeah.
Positive.
Okay, so I'm just going to put the positive. So between 2 and 2.33, for example, 2.1, 7 minus 3 times 2.1, it's still a positive value. Then it becomes negative. Okay. Now I'm just going to do the similar thing for the 2 and 7 over 3 for the signs of the denominator. So signs of x minus 2. Okay, signs of the denominator. And this is negative here, this is positive and positive here. Okay. So now what we need to do is we need to identify the resulting sign by just dividing the signs, okay? The resulting sign. So if you divide a positive to the negative, what do you get?
Negative.
Negative.
Negative, okay?
Negative.
Positive to the positive?
Positive.
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 And
And
negative.
negative to the
Negative.
negative. Okay. So do you remember we needed to find the solutions when this ratio is positive, right? So here is this interval, so between 2 and 7 over 3. Okay. So all of the values for the x from 2 and 7 over 3 are going to give you a positive value for this ratio. So you can check this. For example, 2.1. Do you remember that initially it was 1 divided to x minus 2 is greater than 3. If you substitute 2.1, which is from this interval, right, into here, it becomes 1 divided to the 2.1 minus 2 is more than 3. Then it is becoming like reciprocal of 0.1. Reciprocal of 0.1 is 10, right? So
Yeah.
1 divided to the 0.1 is greater than 3, which is 10 is greater than 3, which is true. Okay, so this is how we are going to solve this kind of inequalities in general, systematically. So we need to, if you have got a ratio in your inequality, you need to try to bring everything into one side and try to identify the signs of the numerator and denominator, and then find the resulting sign of the whole ratio. Okay?
Yeah.
Cool. So we are going to do now, we will come back to this in a moment, where it's a little bit more complicated and sophisticated inequalities. But before we do this, I would like to do a couple of exercises on solution of inequalities, which involves the absolute value sign. Okay, so I would like to try to understand what does it mean that absolute value of the x is less than 3, for example. Okay, so let's assume that you've got some point x on the number line. For example, this point x is more righter than the origin. That the distance between x and the origin is simply going to be the absolute value of the x, right? And if it is possible that your x is a number which is more lefter than the origin, then still the distance between the x and the origin is going to be simply the absolute value of the x. So whenever we say the absolute value of the x, it is basically means that this is the distance between x and the origin, but this x might be in the right-hand side part or in the left-hand side part of the origin, both. Okay, and whenever I say you an equality, absolute value of the x is less than 3, we can write this in terms of the words. So whenever I say that, hey, modulo of the x is less than 3, is such a value for the x, so that the distance between this x and the origin is smaller than 3. Because do you remember the modulo of x is the distance between an x and origin. And whenever I say that modulo of x is less than 3, it means that any point for x, so that distance from the origin is less than 3. Okay, so could you please show me on the number line? So okay, so I think, could you please show me on the number line the points, all of the points where the distance between the origin is going to be less than 3. So yeah, so it's not so difficult to do, right? So for example, this point has the distance from the origin, so 2.5, which is less than 3, or this point, or this point, or this point, this point, this point, and so on. So it is very important for us to understand this expression conceptually. So conceptually means that the distance between x and the origin should be less than 3. Any point which is in distance of 3 or less than 3 from the origin can be solution of this inequality then. Okay, so that is why you can just open the brackets of the module by just saying that any point between -3 and 3 is going to be the solution. At the same time, if I say you that absolute value of the x is greater than 3, it means that any point which is more far away from the origin, more than 3 units, is going to be the solution of this inequality. More than 3 units, right? Not less than 3 units. And this points can be like any point less than -3 or any point greater than 3. Because if you choose any point from here, the distance from the origin is going to be greater than 3, right? Or if you choose any point here, the distance from this point until the origin is going to be greater than 3. So again, so we need to try to understand what actually does this expression mean. Absolute value of the x is more than 3. It means that it is x is such a point so that distance between this point and the origin is more than 3. Okay, and then we can try to solve this in this way. So there is a sign which symbolizes this or, which basically combines the two sets. We call this as the union. So when we are going to just get all of the numbers from one set and all of the numbers from another set and put them together, and we call this as a union sign. So, so there is an intersection sign as well, intersection symbol, which basically finds all of the values which are common in both of the sets. So you need to understand that set is just a bag of items. You've got 2 bags. What you're going to do is you're going to find the items which are in both of the bags. Okay, and this is what does it tell you the intersection. For example, if I say, could you please tell me what is the intersection between -infinity to the 3 and -3 and infinity? It is going to be all of the numbers between -3 and 3. You see, so all of these numbers are located in both of the sets, are common for both of the sets. Okay, so that is why we say that -infinity to the 3 intersection -3 to the infinity is equal to the set to the interval from -3 to the 3. Okay, In general,
Yes.
if I say you, what is the intersection of the intervals between 2 and 4 and 5 and 6? What is this? 2 and
4 and 5.
2 and 4 and 5 and 6, the intersection. Which numbers are common for both of the sets, for both of the intervals?
I think there aren't.
No, there is no. Yeah,
There is no.
not.
Yeah.
There is no number which is common in both of the sets, so that is why we're going to denote this like this, which means no. Okay, no.
Mhm.
This is the notation. If your set doesn't contain anything, so sets are always going to be denoted like this, and just put this 0 with the slash. So it basically means no. There is no item in your set which finds the intersection between these two intervals. Okay, so it is very important for us to understand all of these concepts. So, well, again, so if you've got the absolute value is less than a, it means that x is between minus a and a. If the absolute value of the x is greater than a, it means that either x is greater than a, either x is smaller than minus a. It is coming from its definition of the distance. Okay, so it means that all of the points within the distance of the a and the origin, right? So and this one means that so all of the points whose distance between the origin is greater than a. Okay, so let's solve a couple of exercises. So let's say x minus 3 in the module minus 0.1 is less than 0.4. So I'm just going to put this minus 0.1 into the right-hand side part. It becomes x minus 3 absolute value less than 0.5. What does it mean? It means that the distance between x minus 3 and the origin should be less than 0.5, within 0.5, right? So it means that x minus 3 is less than 0.5 and greater than minus 0.5. Okay, so this is how we are going to open. If you don't understand what is going on, then just like memorize this. Okay, so whenever you've got the absolute value is less than some value, it is becoming like this value inside the absolute value is going to be smaller than value or greater than negative of this value. So then I'm just going to put the minus 3 for both of the sides. So actually, I'm just going to add plus 3 for 3 parts of this inequality. It becomes 2.5 less than x less than 3.5. And that's going to be the solution of this inequality. So all of the numbers between 2.5 and 3.5 are going to be the solutions for this inequality. So let's solve one more problem. So the 2x plus 3 greater than 9. Do you remember when you've got the absolute value greater than 9, you can open this in this way, right? So it is either 2x plus 3 is greater than 9 or 2x plus 3 is less than minus 9. Okay, so this value here should be away from 9, or away from minus 9, so that the distance between this point and the origin is going to be greater than 9. This is the meaning. Okay.
Yeah.
Okay. So I'm just going to solve both of the parts separately. It becomes like 2x is greater than 6, then x is greater than 3. And here I've got 2x is less than minus 12, and x is less than minus 6. Okay. So here I'm just going to draw this like this. So this interval here, all of the numbers smaller than minus 6, and all of the numbers greater than 3. Okay. I mean, as a rule, we do this differently, right? As a rule, we just like denote this like this. Okay. Only from the top.
Yep.
Okay. So by the notation, it becomes like minus infinity to the minus 6 union, right? And 3 and infinity. Not the intersection, right? Because intersection means that there is no solution for your inequality. Okay. So sometimes we need to deal with the quadratic, with an inequality which involves the quadratic functions. Okay, so in this case, what we need to do is we need to try to factorize this first of all. Okay, so that similarly, we need to identify its signs. It becomes 2x in a square minus x minus 3 is less than 0. Oh, let me just, here is the factorization. So we can factorize this in this way. So the x plus 1 times the 2x minus 3 is less than 0. So what we need to do is actually, we need to identify the signs of each of the factors of this quadratic inequality. Okay, so let's do this together. So x plus 1, 2x minus 3. Example. So x plus 1, 2x minus 3 is less than 0. So first of all, we need to find the roots of two factors. What are the roots of both of the factors? It's minus 1, right? And 3 over 2. Okay. We need to first of all find the signs of x plus 1. What are the signs of the x plus 1? If x is less than minus 1, is it positive or negative? X plus 1.
Negative.
Negative, right?
Yeah,
Then it
negative.
becomes positive and positive. Okay.
Yeah.
Similarly, we have to do the same thing for the 2x minus 3. Okay. I've got this minus 1, 3 over 2. If x is greater than 3 over 2, for example, 4, right? It becomes plus, then it becomes minus and minus. Okay. And the resulting is actually is whenever we are simply going to multiply those signs, the resulting sign, the resulting. It becomes like minus and minus. Is it?
Plus.
Minus.
Positive.
Okay. Plus and minus.
Negative.
Plus and plus.
Positive.
Plus. Okay. All of the numbers in between minus 1 and 3 over 2 are going to give you a negative sign. Okay. So that is why if I say, hey, could you please tell me the values for the x so that this inequality is going to be true, you would tell me, hey, all of the x's from this interval from minus 1 until 3 over 2. Okay. Cool. So here it shows the signs. It is like this. So one more thing which I wanted to do here today is to try to solve this inequality. Okay. So if you remember in one of the previous exercises, we try to solve inequality by finding the signs of the numerator and denominator. Okay. But in that example, we used to have just a linear term for the numerator and denominator both. So for this exercise, the numerator and denominator are not linear. If it is the case, then what you have to do first of all is you need to factorize this, as in our previous case. Do you remember in our previous example, I've got the quadratic function involved in the inequality, and first of all, I just try to factorize them, try to multiply, try to write this as a multiplication of the two linear terms. The same what you have to do here. Okay, so now, I'm not going to take into account this term at all because this term is always positive no matter what is the x, right? X squared plus 1 is always positive, and positive number is not going to react, is not going to change any sign in my inequality. So what is important for me is to look for the signs of the three other factors, right? So first of all, we need to find the roots. What are the roots? So what is the root of this factor?
-2.
-2. What about for this one?
3.
3. What about for this one?
-1.
Okay, please note that x cannot be equal to -1, right? It's not a solution, okay? So now what I'm going to do is I'm just going to put the three roots, which I found, -2, -1, and 3. And now I'm going to find the signs of every single factor for this 4 intervals. Okay, so let's start with the x plus 2. X plus 2, is it positive for values less than 2, less than minus 2? Less than minus 2. Let's substitute minus 3. It's negative, right?
No,
Yeah.
Yeah.
negative.
Then it becomes positive here, and positive here. Okay.
Yeah.
Similarly, x plus 1, it becomes negative, negative, then positive and positive, right? You can easily check this by just putting one of the values from this interval into your factor, into your term. What about x 3 minus x? If you substitute minus 1, for example, is it positive?
Yeah.
Yes.
Positive.
Yeah.
Positive. Is it
Minus.
positive here? It
Positive.
is even positive here.
Yeah. Positive here. And
And it's
minus.
negative only here.
Minus.
Yes.
Yeah.
Why?
So if you substitute, for example, 4, it becomes 3 minus 4, which is minus 1, which is negative.
Okay. Understandable.
Okay.
Okay.
For
Okay.
for all of the intervals, it is positive. Okay, so this is what you need to do again. So you need to identify the factors, then you need to identify the signs of all of the factors. And now what we need to do is we need to identify the resultant sign. So minus, minus, plus. What does it give it for your resulting sign?
Plus.
Plus, right? Because 2 minus is plus, multiplied to the plus is plus. Then plus, minus, plus.
Minus.
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 Plus, plus, plus.
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 Plus,
And
plus,
minus.
plus, minus.
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 Minus, okay? There are 2 intervals where the resulting sign is negative. It is here and it is here. And they are the solutions of this huge inequality, okay? So even though it looks very difficult, systematically, it is not so difficult to solve. So it is going to be from minus 2 to the minus 1. So the 2 is going to be included,
Yeah.
right?
Yep.
And minus 1 not, because x cannot be equal to the minus 1. And intersection, sorry, or. So
Union.
yes, so from 3 to the infinity.
3 and quadrate.
From 3 to the infinity. Okay.
Maybe
Is it-
3. It's answer.
Yeah, yes, 3 also.